Welcome back to my office hour. Water budget is a useful tool for water supplying planning. In this video, we will use this tool for estimating the water availability in the Los Angeles watershed area based on the provided data. Background: the Los Angeles River watershed area covers a land area of 834 square miles. The population living within this watershed area is 4.5 million. The 2023 water data for the Los Angeles River watershed area shows the following. 1. The annual precipitation in the area was 10.799 inches. 2. The total stream flow rates entering this watershed was 38.54 cubic feet per second. 3. The total stream flow rates leaving this watershed was 5.21 cubic feet per second. 4. The groundwater inflow was at a total flow rate of 2.9 cubic feet per second. 5. The groundwater outflow was at a total flow rate of 1.07 cubic feet per second. 6. The annual evapotranspiration was 0.635 inch. 7. The average per person water consumption was 101.5 gallons per day. The following unit conversions may be necessary. 1 acre equals to 43,560 square feet. 1 mile equals to 5,280 feet. 1 foot equals to 12 inches. 1 gallon equals to 0.133681 cubic foot. Question 1. According to the 2023 water data, how did the water storage in the Los Angeles River watershed change? Increase, decrease, or remain the same? What was the change in the unit of acre-foot? Question 2. If all the water data and population data remain the same in 2024, how will the per capita water consumption need to be adjusted in order to reach steady state, meaning no change in storage? To perform a water budget for any water storage system, we will first need to clearly identify the control volume. In this problem, the control volume is defined as the total amount of water stored within the area of Los Angeles River watershed. The second step in running a water budget is to identify all the inflows and all the outflows and list their values using a consistent unit. In this particular problem, the inflows include precipitation, streams entering the watershed, and groundwater entering the watershed. The outflows include evapotranspiration, streams leaving the watershed, groundwater leaving the watershed, and human consumption. It is obvious that these inflows and outflows have used different units in the problem statement. Therefore, it is important to work on the unit conversions while listing these items. The annual precipitation is 10.799 inches. This is a length unit. How do we convert this unit into a volume unit? The annual precipitation is an average value. It is like pouring the volume of water into the cube. The depth of the water is the volume divided by the area. If we imagine the watershed to be a cube, then the volume is calculated using area multiplied by height. As shown here, we convert inch to foot and convert acre to square foot. The calculated volume of precipitation water is in the unit of cubic foot. Stream flow rates and groundwater flow rates are reported in the unit of cubic foot per second. Since we want to know the total volume of water through streams or groundwater during this complete year, we will multiply this flow rate by time. We use cubic foot per second multiplied by 60 seconds per minute, then by 60 minutes per hour, then by 24 hours per day, and then by 365 days per year. The unit of the annual evapotranspiration is processed the same way as that of the annual precipitation. The length unit is converted into the unit of cubic foot. Finally, the human consumption is originally given as gallons per day per capita. The term per capita means per person. We can first convert the gallons per day per capita into cubic foot per day per capita. Afterward, we will multiply cubic foot per day per capita by the population number to derive cubic foot per day, and then time 365 days to determine the total volume of water consumed in this year. Once the unit conversions were completed, the third step of performing the water budget is to run the budget calculation, namely change equals total inflows minus total outflows. As shown here, the change is negative 1,484,409,051 cubic feet. This negative value for the change indicates that the volume of water stored in this watershed has decreased. Converted to the unit of acre-feet, the change is negative 34,077 acre-feet. On a daily average, the change in storage of negative 34,077 acre-feet is equivalent to a negative change of 6.76 gallons per day per capita. If steady state must be achieved on a daily basis while all the water data remains the same, the human consumption must be 6.76 gallons per day per capita less. Therefore, if all the water data and population data remain the same in 2024, the per capita water consumption need to be adjusted to 94.74 gallons per day per capita instead of 101.5 gallons per day per capita.